Okay, let's recap for the reciprocal trig functions, which we've done last term, okay? First, I'd just like to write up sine of x. 1 over sine of x we call cosec x, okay? Or there's an abbreviation is sec x, okay? Cosec x. And 1 on cos of x is sec x, okay? And then 1 on tangent x is cotangent x. So we've done this last term. For example, if I have sec pi on 3, I could easily just do is 1 sine pi on 3 is the example, okay? And then you calculate sine pi on 3, which is very easy to do, root 3 over 2. So that's 2 root 3. Okay, so this is how we calculate the value, basically by reciprocal of any trig values. In last term, we've also done some sketch graph of these 3 functions, okay, reciprocal trig functions. I'll just revise that, okay? Sketch graph. So, again, sketch this graph without the use of graphic calculator is actually a very good thing to do because there's some good thinking in it, okay? First, I'm just gonna sketch y is sine of x, okay? And by reciprocal that, because I know this point is pi on 2, and here is 1. Okay, because reciprocal of 1 is still 1. That's no problem. I'm using a different color, okay? And I know that sine 0 is 0. So the reciprocal of 0, 1 on 0, is going to be positive infinity because I have all these positive values here. Therefore, from 1 up, I'm going up as infinity, okay? And same way here, I've got pi here. Okay, that's my pi. And I ended up creating an asymptote when I reciprocal it. Because, again, 1 on 0 is going to be positive infinity. And same way here. That one is 3 pi on 2 and negative 1. So negative 1 reciprocal is still negative 1. But here, I'm actually approaching a negative infinity here. Okay, so this is my 2 pi. Yeah, so same way from here, all this 0 point of sine will be my asymptote. Okay. Okay, I'm not continuing, but that's the way you can easily sketch the graph of sec x. Okay, so the asymptote will be x equals to, there's a pi and 2 pi will be k pi. Okay, so there's pi, 2 pi, and this one is negative pi. Okay, negative 2 pi. That's very easy to understand. Okay, so that's my first graph. Okay, how about my second graph, which is y equals to 1 on cos x, which is sec x. Okay, this is, I'm just going to label here, y equals to cosec x. So now y equals to sec x. Again, I'm just going to draw a cosine graph. With the cosine graph, I've got maximum as 1. Here is pi on 2. Okay, and then here is pi and 3 pi on 2. Okay, similarly, 1 reciprocal will be 1, but as it goes to pi on 2 is close to 0, Okay, pi on 2 cos is 0. So basically we could create another asymptote here. We end up with another asymptote, negative pi on 2. And then here, imagine it goes to 0, okay? The value goes to smaller, therefore the reciprocal goes more negative, okay? Does that make sense? So you can imagine this one as a shift from the cosec x. Okay, so from this graph to that, because cos is a shift of sin of x, therefore sec is also a shift of cosec x. Okay, and the asymptote for this one will be, you've got pi on 2, you've got 3 pi on 2, you've got negative pi on 2. That's going to be x equals to pi on 2 plus k pi. Yeah, that's your asymptote for sec x. Okay, so it's very worth to compare these two graphs, because I know you know that cos x is the shift from sin of x, so therefore the reciprocal is also a shift. Okay. The last one I like to talk about briefly is y equals to cotangent x. I'm just gonna draw y equals to tangent x, and then we can start from there. Okay, so I've written here cotangent x is 1 on tangent x. Okay, so if we imagine an infinity, 1 on infinity, that's going to be approaching 0. Okay, so I've got positive infinity here, therefore this value will be 0. Okay, and again 1 on 0 is positive infinity. Okay, so because I've got value positive side, so I could easily sketch, oops, I could easily sketch here. There's an asymptote here. And again, here is 0, starting from a 0, but because it's negative, approaching 0 from negative, okay? There you go. So that's one period of the tangent, okay? And here, because it's 0, positive, yeah? And then from here, it's negative, and that's 0 here. So this is like my y equals to cotangent x, okay? So basically, remember last term, we've done some interesting calculation to calculate the intersect, yeah? Okay, so if you want to calculate, so again, before that, you can see that cotangent x also has a period of pi. Okay, it also have a period of pi, and it has asymptotes. Yeah, the asymptote will be k pi. Okay. X equals to k pi. Because you can see 0, pi, and then it just keep going. So how do we calculate intersection? If we make cotangent x equals to tangent x, so 1 on tan x equals to tan x, so tan square x equals to 1, and then I can have tan x equals to positive negative 1. And then we could use a unit circle. Basically is pi on 4 plus k pi. Okay, and here is 3 pi on 4 plus k pi. Yeah, but because I've got I've got 90 degrees all here, I could easily say the answer, the intersect are x equals to, there are several ways that you can write the intersection, okay? So you can do pi on 4 plus k pi, x equals to 3 pi on 4 plus k pi. That's one way of writing it. Or because they're all 90 degrees, you can say pi on 4 plus half pi k, okay? So because it's 90 degree, again, you can actually write in that way because it's rotation of half a pi. Okay, so yeah, both ways are correct. This is a recap for reciprocal trig functions. Okay.